adiabatic lapse rates. Now, there's a number of numbers, that's a good way of putting it, related to this. There's what we call the atmospheric lapse rate. There's the wet, or what they call saturated adiabatic rate, which in the activity, it's either going to be written as, WAR, which is wet adiabatic rate, or it might say saturated lapse rate, or it may say saturated adiabatic rate. And depending on if you're working in Fahrenheit or Celsius, it's going to be obviously different because we're dealing with different temperatures. So in Celsius and Fahrenheit, and when you get the questions on the quiz, it'll tell you what lapse rate they want you to use. So it's just a matter of doing the math. But the wet adiabatic rate is, or the saturated, this all means the same thing, is 6 degrees per 1,000 meters, or 3.5 degrees per 1,000 feet. And then there's the dry adiabatic rate. And dry air is going to warm or cool faster. So it goes at 10 degrees per 1,000 meters, or 5.5 degrees per 1,000 feet. This isn't Celsius, this is Fahrenheit. But they will give you the lapse rate. And basically what they're asking you to do is calculate the temperature. And so we'll just do a little practice problem. All right, so it'll give you a temperature at like sea level, right? Sea level 0. And let's say it's 70 degrees, okay? And it'll say the dew point temperature is 40 degrees. You go, okay, and the top of your hill is, I don't know, 9,000 feet. Do it in feet because I can add and subtract 10 very easily. I mean, we'll do it in, no, that's not going to work, but we'll do it in feet, that's fine. Should have done it in Celsius, but I already started with bad numbers. Okay, you don't care, right? I'll just change the numbers. There we go. Okay, so Celsius. So we already said for every 1,000 meters, we're going to drop 10 degrees. So at 1,000 meters, 40 minus 10 is 30, right? Another 1,000 meters. So now we're at 2,000 meters. We're at 20. And we've hit this magic number, the dew point temperature. It's also known as the lifting condensation level, which is abbreviated LCL. And what that means is that's where clouds are going to form, right? Well, when clouds form, that means that the air is saturated, as we learned in our activity last week with the dew point and humidity. When it reaches 100% humidity, the moisture comes out in the form of a cloud, and if it gets too much, then it has to, like precipitate out and stuff like that. So once we've hit this lifting condensation level, we stop using the dry adiabatic rate and we start using the wet adiabatic rate, or the saturated adiabatic rate, till we get to the top of the hill, right? So the saturated rate is 6 degrees for every 1,000. So at 3,000, I'll just say 3K, we're 6 degrees smaller. So 20 minus 6 is 14. At 4, we're at 6 minus, that's 8. At 5, we're at 2. At 6. So you can do it that way, right? You can do it all the way till you get to the top. Once you get to the top and the air descends down the backside, it's always using the dry adiabatic rate. And that's because the air is warming and therefore it can hold more moisture and therefore it's no longer saturated. So therefore it's using the dry adiabatic rate. Okay, doesn't matter how wet the water is, it can't hold on to any more. As soon as it starts descending, it's able to hold on to more moisture. And so always use the dry adiabatic rate coming down the backside of a mountain. Okay. All right. So, yeah. All right. The other way to do it is to create like a little mathematical formula. And some people do it this way and some people don't, but I want to take a few minutes to kind of talk about how that works. So if you take the difference between your sea level, between your current temperature and your dew point temperature, so current minus dew point equals, in this particular case, it's 20 degrees, right? You can divide that by your dry adiabatic rate to find out how many more meters, in this particular case, you have to go. So you take that difference, so difference divided by dry adiabatic rate, and we get 2 in this particular case, right? So we know we have to add 2,000 to wherever we started. In this particular case, we started at sea level. So I should write this down as 2,000. So we know we're at 2,000 feet. If we had started at 1,000, then we just add, now we're at 3,000, so to speak, right? So now we know we're at our dew point temperature at 2,000. So let's say it asks us what's the temperature at the top of the mountain. Okay, so now that we've gotten there, we know we're at 20 degrees. We know we're at 2,000 feet. Now we're going to use the wet adiabatic rate and find out what temperature is at the top. So we go 9,000, which is the height of the top of the mountain, minus where we're at. And that's going to give us, is that 7,000 feet? Or sorry, meters. Okay, and again, we use the wet adiabatic rate. The wet adiabatic rate, because we're above the lifting condensation level. Okay, and what was it? 6 degrees, 5.5 degrees, 6 degrees, 6 degrees, 6 degrees per. Sorry. Oh, schmuckers. I'm in trouble now. Just turn the lampshade a little bit, no one will notice. There we go. All right, so we have to go up 7,000 more feet, so 6 times 7. 7 times 6, 7 times 6 equals 36 plus 7, 42. So we're going to subtract 42 degrees from our current temperature, which in this case is 20. So 20 minus 42 equals negative 22 degrees. That's what the temperature is at the top of my hill. Or you can just keep subtracting and subtracting and subtracting, and eventually you would have gotten there. Okay. So that's how the adiabatic lapse rate activity works. There's some guided practice and a video tutorial on how to do it included in this thing. You just scan the QR code or click on the link. And again, I separated this part out for you, but it is part of last week's activity. It has the little thing and you're supposed to figure out the elevation and all that good stuff. So it ties a lot of the stuff that we talked about together. And then there's also a lab activity. This is optional. You do not have to do this, but I wanted to give people points for already doing it. And then also give you an opportunity, if you came and you heard me say you didn't have to do it yet, that you can work on it this week. So, and then answer the wrap-up questions, and you should be good. All right, any questions? It's not too bad.